Welcome to a journey through the unique wildlife of Australia. As you settle into comfort and prepare for rest, we'll explore the truth behind the reputation, the reality beneath the stories, and the fascinating creatures that call this ancient land home. Take a deep breath, and let's begin. Australia has earned a reputation that precedes it. Australia has an unusually high proportion of venomous species relative to many other continents. When people think of Australian wildlife, they often think first of danger, of snakes hiding in grass, spiders lurking in corners, jellyfish drifting in warm waters. And there's some truth to this reputation. Australia does indeed host a remarkable concentration of venomous creatures. But as we'll discover, the story is more nuanced than the headlines suggest, more interesting than simple fear. The reason for this concentration of venom lies deep in geological time. This is due to evolutionary isolation, where snakes, spiders, and marine animals diversified and retained potent venoms. Australia separated from other landmasses millions of years ago, becoming an island continent where evolution took its own unique paths. Species evolved in isolation, adapting to Australian conditions without competition from animals that dominated other continents. Venomous snakes diversified into dozens of species. Spiders evolved potent toxins. Marine creatures developed stings and poisons. In this isolated laboratory of evolution, venom became a common strategy, refined over millions of years. What makes Australia particularly notable isn't just that venomous species exist, but where they exist. Many highly venomous species live close to people, in backyards, suburbs, and beaches. Unlike some countries where dangerous animals live only in remote wilderness, many of Australia's most venomous creatures are comfortable in human-modified landscapes. Brown snakes hunt mice in suburban gardens. Redback spiders nest under outdoor furniture. Box jellyfish drift near popular swimming beaches. The boundary between human space and wild space is blurred, permeable. This overlap creates inevitable encounters. Because of this overlap, encounters are more common than people expect. A farmer working in a field might disturb a snake. A child playing in a backyard might reach near a spider's web. A swimmer might brush against a jellyfish. These encounters aren't necessarily the result of aggressive animals, they're simply the mathematical result of humans and wildlife occupying the same spaces. When millions of people live and work in environments also inhabited by venomous species, interactions will occur. The roster of dangerous species extends beyond venom. Australia's most dangerous animals include not just venomous species but also large mammals. Horses, cattle, kangaroos. In certain circumstances, these animals can cause serious injury or death through physical force rather than toxins. A kick from a horse, a charge from a bull, a collision with a kangaroo, these are dangers of mass and momentum rather than venom. The complete picture of risk includes both the venomous and the simply large. The numbers might surprise you. Between 2001 and 2017, 541 animal-related deaths were recorded in Australia. Over 16 years, 541 deaths. That's an average of about 34 deaths per year across the entire continent. To put that in perspective, Australia's population during this period averaged around 23 million people. We're talking about a tiny fraction of a percent, a risk that exists but remains remarkably small on a population level. Context is everything when assessing risk. Despite its reputation, the overall risk of dying from an Australian animal is low compared to heart disease or car crashes. Cardiovascular disease kills tens of thousands of Australians each year. car accidents claim more than 1,000 lives annually. By comparison, animal-related deaths, while tragic, represent a much smaller threat to public health. The dramatic nature of animal encounters, the fear they inspire, the stories they generate, gives them an outsized presence in our imagination compared to their actual statistical danger. Medical advances have transformed outcomes. Modern antivenoms and intensive care have drastically reduced deaths from bites and stings. 50 years ago, a bite from a funnel web spider or an inland taipan could easily be fatal. Today, with proper treatment, survival is likely. Antivenoms neutralize toxins. Intensive care units provide mechanical ventilation and support failing organs. Paramedics can administer life-saving treatment in the field. Medical science has fundamentally changed the equation, turning many once fatal encounters into survivable emergencies. The approach to coexistence emphasizes education over elimination. Public safety campaigns emphasize avoidance and awareness rather than killing wildlife. Modern Australian society generally recognizes that these animals are part of the natural heritage, that they have ecological roles, that coexistence is both possible and preferable to extermination. Safety campaigns teach people where dangerous animals live, how to avoid encounters, what to do if bitten or stung. It's a philosophy of respect and caution rather than fear and destruction. Most dangerous encounters have a human element. Many dangerous interactions result from habitat overlap and human behavior rather than animals actively seeking people. A snake doesn't wake up planning to bite a human. A spider doesn't set out to attack. These animals are defensive, not aggressive. They bite or sting when threatened, when stepped on, when cornered, when defending themselves. If we understand this, if we recognize that our behavior influences risk, we can dramatically reduce dangerous encounters simply by being aware, being cautious, being respectful of the wildlife around us. The truth about danger in Australia often surprises people. The animals that actually cause the most deaths are not the ones that dominate the headlines or feature in sensational documentaries. The most dangerous animal in Australia is not what you'd expect. Horses caused more deaths than any other animal group between 2001 and 2017, with 172 deaths. Horses. Not snakes, not sharks, not spiders. Horses killed more people than all of these combined. 172 deaths over 16 years, averaging about 11 deaths per year. These noble animals, domesticated for thousands of years, companions to humans, prove more statistically dangerous than any of Australia's famous venomous creatures. The nature of horse-related deaths is relatively straightforward. Most horse-related fatalities involve falls during riding or handling. Horses are large, powerful animals. Even a calm, well-trained horse stands taller than most humans and weighs 500 kilograms or more. A fall from horseback can result in severe head trauma, spinal injuries, or being crushed if the horse falls on the rider. Handling horses on the ground carries risks too. A kick can be lethal, and even unintentional contact can cause serious injury when dealing with an animal that size. Experience doesn't eliminate risk. Many victims are experienced riders, showing the inherent risk of large animals. This is perhaps the most sobering aspect. These aren't primarily deaths of inexperienced people making obvious mistakes. Many victims were skilled riders, people who'd spent years or decades around horses, people who understood horse behavior and knew proper safety protocols. It illustrates that when you regularly interact with large, unpredictable animals, risk accumulates over time. Even rare accidents become probable when you engage in an activity thousands of times. Another large domesticated animal follows closely in the statistics. Cattle caused 82 deaths in the same time frame. Again, far more than sharks or venomous snakes. Cattle are gentle in most circumstances, but they're massive animals, and bulls in particular can be territorial or aggressive. A charging bull or a panicking cow in a confined space becomes a ton of moving muscle with horns. The power differential between human and cattle is immense. These deaths have a clear pattern. Many cattle deaths involve farm workers being crushed or gored. Agriculture is dangerous work, and working with large livestock is one of the specific hazards. A farmer might be kicked while milking, trampled during mustering, crushed against a fence by a spooked animal, or gored by a bull. These incidents often occur in routine farm operations, everyday activities repeated countless times, until the one time something goes wrong. Domesticated animals account for another significant category. Dogs were responsible for 53 deaths, mostly from bites and some from falls. This might seem shocking. Dogs, humanity's oldest companion, are loyal friends, but dogs are predators with powerful jaws. Fatal dog attacks, while rare, tend to involve vulnerable victims like young children or elderly people, multiple dogs acting in a pack, or large, powerful breeds. Some deaths categorized under dogs actually involve falls that occur when people are knocked over by enthusiastic or aggressive dogs, particularly elderly people who fracture their hips or hit their heads. Even native herbivores appear on the list. Kangaroos caused 37 deaths, largely from vehicle collisions. Kangaroos are not aggressive toward humans under normal circumstances. They're herbivores, typically shy, more likely to flee than attack. But they're large animals that move unpredictably, and they're active at dawn and dusk when visibility is poor. A kangaroo hopping into the path of a vehicle can cause a collision that kills the driver or passengers. These are traffic fatalities, not attacks, but they're still deaths caused by the animal. Now we reach the first venomous animal on the list. Snakes caused 37 recorded deaths between 2001 and 2017. 37 deaths in 16 years, despite Australia having more venomous snake species than almost anywhere on Earth. That's remarkable. It speaks to the effectiveness of antivenoms, the speed of medical care, and perhaps also to the fact that snakes generally avoid humans when possible. Most snake bites aren't fatal, and most snakes would rather flee than fight. An unexpected entry appears next. Bees were responsible for 31 deaths, mostly due to anaphylaxis. Not venom in the traditional sense, the amount of venom in a bee sting is tiny, medically insignificant for most people. But for those with severe allergies, a sting can trigger anaphylactic shock, a cascade of immune responses that can kill within minutes if untreated. These are typically European honeybees, introduced species, not native Australian wildlife. But they're present throughout the country, common in both urban and rural areas. Finally, the animal that dominates news and popular fear. Sharks caused 27 deaths in that same period. 27 deaths over 16 years. That's fewer than 2 deaths per year on average across the entire Australian coastline. For context, millions of Australians swim, surf, and dive in the ocean every year. The statistical risk to any individual is vanishingly small. Yet sharks occupy an enormous space in our collective fear, their danger amplified by primal terror of being eaten, by media coverage that treats each incident as headline news, by movies and documentaries that present them as mindless killers rather than wild animals following their nature. Australian snakes have evolved into some of the most venomous creatures on Earth, their toxins refined by millions of years of predation on fast-moving, warm-blooded prey. The classification of Australia's dangerous snakes reveals a pattern. Most of Australia's dangerously venomous land snakes are front-fanged elapids. The family Elapidae includes cobras, mambas, sea snakes, and coral snakes worldwide. Australian elapids have evolved hollow, fixed fangs at the front of their mouths, allowing them to inject venom deep into prey or threats. Unlike vipers, which have folding fangs, elapid fangs are always erect, shorter, but extremely efficient at delivering venom. The nature of elapid venom sets them apart. Their venoms are fast-acting and primarily neurotoxic. While some snake venoms work slowly, destroying tissue over hours, Australian elapid venoms are designed for speed. They target the nervous system, disrupting the signals that control muscle movement, breathing, and heart function. This makes sense evolutionarily. These snakes hunt agile prey like lizards and small mammals. A slow-acting venom would allow prey to escape and die far away where the snake couldn't find it. Fast neurotoxins immobilize prey quickly. The effects can seem paradoxical. Many Australian snake venoms cause little local tissue damage but severe systemic effects like coagulopathy and neurotoxicity. Where you're bitten might show minimal swelling or pain. There might not be dramatic local symptoms to alarm you. But inside your body, the venom is disrupting blood clotting, interfering with nerve signals, causing internal hemorrhaging. This makes Australian snake bites particularly dangerous. The lack of immediate, obvious symptoms can lead people to underestimate the severity of the bite. One species dominates the fatality statistics. Eastern brown snakes are responsible for the majority of snakebite fatalities. They're not the most venomous Australian snake, that distinction goes to the inland taipan. But brown snakes are the most dangerous in practice because of where they live and how they behave. They're common, they're fast, they're nervous and quick to strike, and they often live in areas where people work and live. The numbers tell the story clearly. Brown snakes have killed more than 21 people since 2000. In 2.5 decades, more than 21 confirmed deaths. No other Australian snake comes close to this number. The brown snake's combination of potent venom, widespread distribution, and defensive temperament makes it Australia's most dangerous snake by any practical measure. Their distribution ensures frequent encounters. Eastern browns occur widely across eastern and southern Australia, including suburbs and farmland. They're found from Cape York in northern Queensland down through New South Wales, Victoria, and into South Australia. That's a huge geographic range covering most of Australia's population. And they thrive in modified landscapes, farms, suburbs, parks, anywhere with rats and mice to eat. You don't need to go into remote wilderness to encounter an eastern brown snake. They might be in your backyard. The venom's effects are devastating. Their venom can cause paralysis and internal bleeding. The neurotoxic components attack the nervous system, potentially causing paralysis of the respiratory muscles, making it impossible to breathe without mechanical ventilation. The coagulant toxins disrupt the blood's ability to clot normally, causing internal hemorrhaging, stroke, or organ failure. It's a 1-2 punch of different toxin types working synergistically. Speed is critical in brown snake bites. Symptoms of severe brown snake envenomation can appear within 15 minutes. A quarter of an hour from bite to serious symptoms. This rapid onset means there's little time to waste. If someone is bitten by what might be a brown snake, they need medical attention immediately, not in an hour. not after waiting to see if symptoms develop. The window for effective treatment is narrow. The danger extends to animals as well as humans. Brown snakes, tiger snakes, and red-bellied black snakes account for most serious envenomations in pets and livestock. Dogs investigating interesting smells, cats hunting in long grass, cattle in paddocks, horses in stables, all are at risk. Veterinarians in Australia must be experienced in treating snake bites in animals, administering antivenoms, and managing the complications. For farmers, losing livestock to snake bite is a recognized hazard of the Australian agricultural landscape. Tiger snakes complete the triumvirate of most dangerous species. Tiger snakes are among the 3 most commonly implicated in serious animal envenomations. Along with brown snakes and red-bellied blacks, tiger snakes cause significant numbers of bites requiring medical treatment. They're found in southern Australia, often near water, and like browns, they're nervous and defensive. Their venom is highly toxic, though often delivered in smaller quantities than brown snakes. Still, untreated tiger snake bites can be fatal. Beyond the brown snake and tiger snake, Australia hosts several other species whose venom potency ranks among the most powerful on Earth. One species holds a grim record. The inland taipan is considered the world's most venomous land snake based on LD50 tests. LD50 is a measure of how much venom is required to kill 50% of test animals, usually mice. By this measure, the inland taipan's venom is the most toxic of any land snake anywhere. A single bite could theoretically kill 100 adult humans. The venom is a cocktail of neurotoxins, hemotoxins, myotoxins, toxins that attack nerves, blood, and muscle tissue simultaneously. It's frightening to contemplate. But theoretical toxicity doesn't translate directly to danger. Despite its venom, the inland taipan is shy and rarely encountered. It lives in remote regions of inland Queensland and South Australia, in gibber deserts and dry floodplains where few people venture. It's a specialist predator of mammals, particularly the long-haired rat. When threatened, it generally tries to flee rather than fight. There are very few recorded bites of humans by inland taipans, and with modern medical care, all victims have survived. It's the most venomous snake you're least likely to encounter. The coastal relative is far more dangerous in practice. Coastal taipans have the 3rd most toxic land snake venom in the world. Less toxic than the inland taipan and the eastern brown, but still extraordinarily potent. Unlike their inland cousins, coastal taipans live in populated regions of northern and eastern Australia. They're found in sugarcane fields, coastal scrub, and even suburban areas in far north Queensland. They're large snakes, often over 2 meters long, fast, alert, and nervous. Their physical characteristics add to the danger. Coastal taipans have the longest fangs of any Australian snake, up to 12 millimeters. Those long fangs can inject venom deep into tissue, delivering it directly into muscle or even blood vessels. The depth of injection affects how quickly venom enters the bloodstream and how severe the envenomation becomes. Longer fangs make the bite more medically serious. The venom yield is substantial. A coastal taipan bite can deliver 120 to 400 milligrams of venom. The average lethal dose for an adult human is estimated at around 20 to 40 milligrams. A single bite could deliver 10 times the lethal dose or more. Fortunately, bites don't always involve full envenomation. The snake may deliver a dry bite with no venom, or a partial dose. But the potential is there for massive envenomation with dire consequences. Another group of snakes uses different hunting strategies. Common death adders use ambush tactics. Unlike most Australian snakes, which actively hunt, death adders are sit-and-wait predators. They bury themselves in leaf litter or sand with only their head exposed, their tail visible wiggling like a worm or caterpillar to lure prey. When a lizard, bird, or small mammal approaches, the death adder strikes with incredible speed, injecting venom and then waiting for the prey to die. This ambush strategy makes them dangerous to humans who might step on a concealed death adder without ever seeing it. Their venom works with frightening efficiency. Death adder venom causes rapid paralysis if untreated. The neurotoxins block signals between nerves and muscles. Paralysis begins in the bitten limb, then spreads to the trunk, eventually affecting the diaphragm and intercostal muscles that control breathing. Without treatment, victims can die from respiratory failure within hours. The name death adder is well earned, though they're not true adders at all. They're Australian elapids that happen to look and behave somewhat like adders from other continents, a case of convergent evolution. One species is often encountered but rarely lethal. Red-bellied black snakes are highly venomous but rarely fatal to humans. They're common along the east coast of Australia, often found near water. They're beautiful snakes, glossy black above with a vivid red or pink belly. Despite their potent venom, they're relatively placid for an Australian elapid, generally choosing to flee rather than fight. When they do bite, they often don't inject much venom, perhaps because they evolved to prey on frogs and lizards rather than large mammals. Deaths are extremely rare, though bites are medically significant and require hospital treatment. The overall picture is one of ongoing medical challenge. Snakes are responsible for dozens of serious envenomations each year. Even with antivenom and modern medicine, snake bites remain a significant cause of emergency department visits in Australia. Agricultural workers, wildlife handlers, bushwalkers, and even suburban residents continue to be bitten. Each case requires careful assessment, often laboratory testing to determine if envenomation has occurred, and hours of hospital monitoring. But the trend is positive. Rapid treatment and antivenom have dramatically reduced fatalities. Decades ago, snake bite fatality rates were much higher. Today, with rapid access to medical care, appropriate first aid, and specific antivenoms for most major species, the vast majority of snake bite victims survive. It's a medical success story, a case where scientific understanding of venoms and development of targeted treatments has turned many certain deaths into survivable emergencies. Australia's reputation for dangerous spiders is well earned historically, but modern medicine has transformed these once deadly encounters into survivable, if unpleasant, experiences. One species stands above all others in medical significance. The Sydney funnel web spider is Australia's most medically important spider. Before antivenom, funnel web bites killed 13 people between 1927 and 1980. These are large, aggressive spiders with huge fangs capable of penetrating fingernails. They're found in moist forest areas around Sydney and in other parts of New South Wales. Male funnel webs wander during mating season, sometimes entering homes, and they're remarkably aggressive when threatened, rearing up and baring their fangs. The venom works with terrifying speed. Its venom can cause life-threatening symptoms within 15 to 30 minutes. The venom contains atracotoxin, a neurotoxin that causes massive release of neurotransmitters, leading to uncontrolled muscle spasms, salivation, tears, sweating, and potentially respiratory failure. Victims experience severe pain at the bite site, followed rapidly by numbness around the mouth, nausea, vomiting, and profuse sweating. Without treatment, severe envenomations progress to respiratory distress and death within hours. Gender matters significantly in funnel webs. Male funnel webs are more dangerous than females. Males produce venom about 5 times more toxic to primates than females do. This is unusual. In most venomous creatures, females are more dangerous. But male funnel webs, wandering in search of mates, are more likely to encounter humans, and their venom is more dangerous when they do. It's a dangerous combination of behavior and biochemistry. Geographic distribution determines risk. Funnel web spiders are mainly found in New South Wales, including Sydney. The greatest risk is in and around Australia's largest city, where millions of people live and work in funnel web habitat. They're found in gardens, under houses, in rockeries, in garages and sheds. During rainy periods or in warm, humid conditions, funnel webs become more active and more likely to enter homes. But everything changed in 1981. No deaths have occurred since antivenom was introduced in 1981. Over 4 decades without a single fatality. This is one of medicine's quiet triumphs. Funnel web antivenom, developed through research at the Commonwealth Serum Laboratories, neutralizes the venom effectively. Given promptly, it reverses symptoms and prevents death. Hundreds of people have been bitten since 1981, many severely, but with antivenom, all have survived. The danger isn't limited to Sydney species. Some other funnel web species beyond Sydney are also medically significant. Species like the tree-dwelling funnel webs and northern funnel webs can cause severe envenomations. They may have slightly different venom compositions, but the Sydney funnel web antivenom appears effective against these species as well. The principle remains the same: aggressive spiders with potent neurotoxic venom, managed effectively through antivenom and supportive care. Another species once claimed lives regularly. Redback spiders have venom capable of killing humans. Before antivenom, at least 14 deaths were attributed to redback bites. The venom contains neurotoxins that cause severe pain, sweating, muscle rigidity, nausea, and potentially respiratory failure. Historical records describe excruciating bites causing days or weeks of suffering, sometimes ending in death, particularly in children or elderly victims. And redbacks live intimately alongside humans. Redbacks often live close to people, under furniture, sheds and letterboxes. They build messy cobwebs in sheltered locations, exactly the kinds of places humans frequently reach without looking. A hand reaching behind an outdoor cushion, feeling under a letterbox for mail, moving items in a shed, these ordinary actions can result in bites. Redbacks are found throughout Australia, in cities, suburbs, and rural areas. They're probably the spider most Australians are personally familiar with. The transformation has been complete. The combination of antivenom and supportive care has reduced spider mortality to nearly zero. The last confirmed death from a spider bite in Australia was in 1979, over 40 years ago. Since then, thousands of people have been bitten by funnel webs, redbacks, and other dangerous species. Many have become seriously ill. But with prompt medical care and antivenom when needed, all have survived. The modern experience of spider bite is very different from the past. Today, spider envenomation usually causes severe pain rather than death. A redback bite can cause hours or days of pain, muscle aches, sweating, and nausea. A funnel web bite can cause intense local pain and systemic symptoms. But these are survivable medical events, unpleasant but temporary. The fear remains: perhaps appropriately, these are still dangerous animals deserving of respect. But the terror of certain death has been replaced by the expectation of unpleasant but manageable medical treatment. Australia's tropical waters contain some of the most dangerous creatures on Earth, nearly invisible, drifting with currents, capable of killing in minutes. One creature tops the danger list. The box jellyfish is often ranked as Australia's most dangerous marine animal. The large box jellyfish, Chironex fleckeri, has caused more than 60 confirmed deaths in Australian waters since records began. Its bell can be the size of a basketball, trailing up to 60 tentacles several meters long. It's found in tropical and subtropical waters, particularly along the northern coast, in harbors, estuaries, and coastal beaches. The speed of the effects is what makes box jellyfish so deadly. Its sting can cause cardiac arrest within minutes. The venom is extraordinarily potent, perhaps the most toxic of any animal venom. It causes immediate intense pain, described as burning and searing. But worse, it affects the heart directly, causing irregular rhythms or complete cardiac arrest. Victims have died in as little as 2 to 5 minutes after severe stings. The speed of onset leaves little time for rescue or treatment. The delivery mechanism is horrifically efficient. Tentacles carry millions of venom-loaded stinging cells. Each cell, called a cnidocyte, contains a coiled harpoon loaded with venom. When stimulated by contact, the harpoon explodes outward at incredible speed, penetrating skin and injecting venom. A single tentacle contains thousands of these cells. A severe sting can involve multiple tentacles, each delivering millions of stinging cells, each injecting a dose of venom. The cumulative effect can be massive envenomation in seconds. Geographic distribution determines risk. Box jellyfish are mainly found in tropical northern waters. They're seasonal, most common from October to May during the wet season. They're attracted to shallow water, estuaries, and beaches, exactly where people swim. Cairns, the Whitsundays, Darwin, popular tourist destinations all fall within box jellyfish range. The overlap between box jellyfish habitat and popular swimming areas makes them a significant public health concern in northern Australia. Tragedies have occurred regularly. Multiple deaths have occurred, particularly among swimmers and children. Children are at greater risk because of their smaller body size. The same amount of venom is more concentrated, more quickly overwhelms their systems. Many deaths have occurred when children were swimming in shallow water, sometimes only waist deep, at beaches where box jellyfish weren't expected or where people were unaware of the danger. First aid can make a difference. Vinegar is recommended to inactivate unfired stinging cells. Vinegar doesn't neutralize the venom already injected, but it prevents unfired stinging cells still on the skin from firing. After a sting, tentacle fragments may still be adhering to the skin, covered with millions of cells that haven't yet fired. Dousing the area with vinegar for at least 30 seconds inactivates these cells, preventing further venom injection. It's why vinegar bottles are stationed at many northern beaches. Size doesn't determine danger with jellyfish. Irukandji jellyfish are tiny but can trigger a potentially fatal syndrome. Irukandji are small box jellyfish, sometimes no bigger than a thumbnail, with tentacles a few centimeters to a meter long. Despite their tiny size, their sting can cause Irukandji syndrome, severe lower back pain, nausea, vomiting, anxiety, restlessness, sweating, dangerously high blood pressure, and potentially heart failure or stroke. It's called Irukandji syndrome after the Aboriginal people of the area where it was first characterized. The delayed nature makes diagnosis difficult. Irukandji symptoms can be delayed. Unlike large box jellyfish stings that cause immediate intense pain, irukandji stings may be barely noticed initially. Symptoms typically develop 30 minutes to an hour after the sting, sometimes longer. By the time a victim realizes something is seriously wrong, they may no longer be near medical help. The delayed onset has caused deaths when victims were hours from hospitals by the time symptoms became severe. Public health measures are extensive. Tourist signage and seasonal beach closures reduce injuries. During stinger season, many northern beaches display prominent warning signs. Some beaches close to swimming entirely. Stinger-resistant enclosures, netted areas where jellyfish theoretically cannot enter, allow some swimming in protected areas. Tourist education emphasizes the real danger, the need for protective stinger suits, and the importance of staying out of the water entirely during high-risk periods. The threat shapes entire communities. Jellyfish envenomations are a major reason for first aid training in northern coastal communities. Lifeguards, tour operators, resort staff, and many residents know how to recognize jellyfish stings, administer vinegar, and manage the immediate aftermath. Medical facilities in northern coastal areas stock jellyfish antivenom and are experienced in managing severe stings. It's a regional adaptation to living alongside one of the world's most dangerous creatures. Beyond the jellies that drift with currents, other marine creatures hide venom in spines and fangs, waiting on the seafloor or in the shallows to defend themselves against threats. One fish is particularly feared by those who walk in shallow water. Stonefish are among the world's most venomous fishes. They're perfectly camouflaged to look exactly like encrusted rocks on the seafloor. 13 dorsal spines, each connected to a venom gland, can pierce through soft-soled shoes or bare feet. The stonefish doesn't attack, it simply sits motionless, and people step on it not knowing it's there. The mechanism of injury is accidental. Many injuries happen when people accidentally step on them. Wading in shallow water, walking on reef flats, or shuffling through sand can result in stepping directly onto a stonefish. The weight of the body drives the spines deep into the foot, injecting venom under pressure. The victim usually doesn't know what happened until the pain hits seconds later. The pain is legendary. Their spines inject venom, causing excruciating pain and tissue damage. The pain is described as the worst imaginable, causing grown adults to scream and lose consciousness. It radiates up the limb, intensifying over time, lasting hours even with treatment. The venom causes local tissue damage, swelling, and potentially systemic effects including shock, heart rhythm disturbances, and paralysis in severe cases. First aid is important but limited. Hot water immersion is a common first aid treatment for fish stings. Heat denatures some of the protein toxins in fish venom, providing some pain relief. The water should be as hot as the victim can tolerate without causing burns, maintained for 30 to 90 minutes. It doesn't eliminate the venom, but it can significantly reduce pain while the victim is transported to hospital. Professional medical care, including antivenom for stonefish stings, provides more definitive treatment. One small creature carries one of nature's most deadly toxins. Blue-ringed octopuses carry tetrodotoxin. This is the same toxin found in pufferfish, one of the most potent biological toxins known. Tetrodotoxin blocks sodium channels in nerves and muscles, causing paralysis. There's no antivenom, no specific antidote. Treatment is purely supportive, mechanical ventilation to breathe for the victim until the toxin clears naturally from the body. The effects develop quickly and completely. Their venom can cause paralysis and respiratory failure. Within minutes of a bite, numbness begins around the mouth and face, spreading to the limbs. Muscle weakness follows. Within an hour, the victim may be completely paralyzed, unable to move, unable to breathe, but often fully conscious and aware. It's a terrifying prospect, conscious paralysis, unable to even signal for help. Death occurs from respiratory failure if mechanical ventilation isn't provided. The danger is in the lack of warning. Blue-ringed octopus bites are often painless at first. The victim might feel a small prick or nothing at all. The octopus is tiny, and its bite is small. People have been bitten while handling shells or rocks in tidal pools, not even realizing an octopus was present. Only when symptoms begin do they realize something is seriously wrong, and by then, time is critical. Shells can contain hidden danger. Certain cone snails have venomous harpoons. Cone snails are marine gastropods found in tropical waters. They hunt fish, worms, or other mollusks using a harpoon-like radula tooth loaded with venom. The harpoon is barbed and is shot into prey with considerable force. The venom is a complex cocktail of peptides called conotoxins, which can cause paralysis, respiratory failure, and cardiac arrest in humans. The scenario is predictable. Cone snail stings usually occur when shells are picked up. A beautiful cone shell on the beach or in shallow water is tempting to collect. But the snail inside may be alive. When picked up, it can extend its proboscis and fire its harpoon into the collector's hand. The venom is injected deep, and symptoms begin quickly. There's no anti-venom, only supportive care. The diving community takes marine venoms seriously. Divers are trained to treat stonefish and cone snail stings as emergencies. The protocols are clear: get the victim out of the water, apply first aid as appropriate, and evacuate to medical care immediately. In remote locations, this might mean hours of supporting breathing manually for a paralyzed victim until professional help arrives. The marine environment adds complexity to these emergencies: remote locations, limited communications, the need to get victims back to shore before treatment can begin. In Australia's tropical north, the rivers and estuaries are home to predators that have remained largely unchanged for millions of years, perfectly adapted to their hunting strategy. One species is the undisputed apex predator. Saltwater crocodiles are Australia's largest living reptiles. They're the largest living reptiles in the world, in fact, surpassing even the Nile crocodile in maximum size. These are ancient predators, their body plan perfected over 65 million years of evolution. They're more closely related to birds than to lizards or snakes, remnants of the age of dinosaurs still ruling their domains. Their size alone makes them formidable. They can exceed 5 meters and weigh over 500 kilograms. A 5-meter crocodile is longer than most cars. 500 kilograms is the weight of a large motorcycle. Imagine that mass combined with powerful jaws, thick armor, incredible strength, and predatory instincts honed over millions of years. They're built to kill large prey, and humans, unfortunately, fall within their size range of prey items. Their adaptability expands their range. They tolerate both salt and freshwater environments. Despite the name saltwater, these crocodiles are equally at home in freshwater rivers, billabongs, and even hundreds of kilometers inland. They can regulate salt in their bodies through specialized glands, allowing them to traverse coastal waters, swim between rivers, and colonize new territories. This adaptability means nowhere in northern Australia's waterways is definitely safe from crocodiles. The statistics are sobering. Crocodiles caused 21 deaths between 2001 and 2017. 21 confirmed fatalities in 16 years, more than sharks. Every death is a tragedy, often a person going about ordinary activities near water, fishing, swimming, camping, boating. Unlike many animal dangers where victims were engaging in risky behavior, crocodile victims are often simply people using waterways that happen to be crocodile habitat. Location determines risk. Many attacks occur near river mouths and tidal creeks. Crocodiles ambush prey at the interface between land and water, the places where animals must come to drink, where fish are abundant, where prey is predictable. River mouths and tidal creeks are prime crocodile habitat, but they're also where people camp, fish, and launch boats. The overlap is extensive in the north, where many popular fishing and camping spots are in optimal crocodile territory. The hunting technique is frighteningly effective. Crocodiles use explosive ambush strategies from the water's edge. A crocodile can remain motionless in murky water for hours, just eyes and nostrils above the surface, completely submerged in shallow water, or hidden among vegetation at the water's edge. When prey approaches within range, the crocodile explodes from concealment in a burst of speed, seizing the victim in jaws capable of crushing bone, dragging them into deeper water within seconds. The attack is so fast most victims have no chance to react. Survival in the water is unlikely. Fatal attacks often involve drowning. Even if the initial bite isn't immediately fatal, the crocodile performs a death roll, spinning rapidly underwater while gripping the victim. This disorients the victim, causes additional injuries, and usually results in drowning. Crocodiles are adapted to holding prey underwater, using their breath-holding ability to simply wait until the victim stops struggling. It's a hunting strategy millions of years old, brutally effective. Mitigation strategies are extensive. Warning signs and exclusion zones are widely used. Throughout northern Australia, signs warn of crocodile danger at boat ramps, fishing spots, and swimming areas. Some areas are designated as high risk and have restricted access. These aren't suggestions. People have died ignoring warning signs, convinced they knew better or that they'd be quick or lucky. The signs exist because that location has crocodile activity. Active management complements signage. Management programs remove crocodiles from high-use areas. Problem crocodiles, those that show up in populated areas or show concerning behavior, are trapped and relocated or removed. Rangers conduct regular monitoring. Crocs near swimming areas, boat ramps, or communities are prioritized for removal. It's a constant effort, managing wildlife that reproduces successfully and continually recolonizes cleared areas. Conservation complicates the picture. Despite their danger, crocodiles are legally protected due to conservation success. Saltwater crocodiles were hunted nearly to extinction for their valuable skins by the 1960s. Legal protection since the early 70s has allowed populations to recover dramatically. They are now abundant, perhaps more abundant than at any time in the last century. This success creates conflict. Locals want fewer crocodiles for safety, but national and international conservation ethics demand their protection. It's a tension between human safety and wildlife conservation with no easy answers. Few animals inspire the primal fear that sharks do, yet the statistics reveal a creature far less dangerous than popular imagination suggests. 3 species account for most serious incidents. Bull sharks, tiger sharks, and great white sharks are most implicated in serious attacks. These 3 species are large, powerful, and inhabit areas where humans swim, surf, and dive. They're responsible for most unprovoked attacks on humans worldwide, not just in Australia. Understanding their behavior helps understand risk. Bull sharks are particularly concerning because of their range. Bull sharks tolerate freshwater and enter rivers and estuaries. They've been found hundreds of kilometers up rivers, far inland from the coast. They can thrive in murky, shallow water where visibility is low. Their tolerance for freshwater and willingness to hunt in shallow, murky environments means they're present in areas where people assume sharks won't be: rivers, river mouths, harbors. Great whites are the stereotypical dangerous shark. Great whites are powerful ambush predators. They hunt seals and other marine mammals, typically attacking from below, using speed and surprise to deliver devastating bites. Their hunting strategy can result in mistaken identity attacks on humans, particularly surfers who, from below, have a silhouette somewhat similar to seals. Great whites are most common in southern Australian waters, particularly around seal colonies. Tiger sharks are less selective feeders. Tiger sharks are opportunistic feeders. They'll eat almost anything: fish, turtles, birds, garbage, carrion. This lack of selectivity means they're more likely to investigate and bite unusual objects, including humans. They're common in tropical and subtropical waters, often found in murky coastal waters where their pattern provides camouflage. The typical scenario reveals the pattern of encounters. Many shark incidents involve surfers and swimmers. Surfers, particularly, are at elevated risk. They spend hours in the water, often during dawn and dusk when sharks are most active, in areas where sharks hunt, sometimes near seal colonies or river mouths. Swimmers in murky water, particularly in areas where sharks are present, are also at risk. Divers, interestingly, are at relatively low risk, perhaps because they're more aware and cautious. The actual numbers provide needed perspective. Sharks caused 27 deaths between 2001 and 2017. 27 fatalities over 16 years, across thousands of kilometers of coastline, with millions of ocean user hours logged by swimmers, surfers, and divers. Any individual's risk in any given swim or surf session is extraordinarily low. You're statistically more likely to die driving to the beach than from a shark in the water. Context is crucial. This is far fewer than horses or cattle. The comparison bears repeating because it illustrates how poorly calibrated our fears are. Horses killed more than 6 times as many people as sharks in this period. Cattle killed more than 3 times as many. Yet people fear sharks intensely while considering horses safe companions. It's a profound mismatch between perceived and actual risk. Management strategies are controversial. Shark spotter programs and drumlines aim to reduce risk. Various states use different approaches. Some use traditional shark nets and drumlines, which catch and kill sharks in an attempt to reduce populations near beaches. Others use shark spotters, people positioned on high points scanning for sharks and alerting beach users. Some deploy aerial drones. Some test shark repellent technologies. Each approach has proponents and critics. Alternatives to lethal control are expanding. Some states use non-lethal deterrent technologies and tagging research. Shark tagging programs track individual sharks, providing data on movements and behavior. When tagged sharks approach certain beaches, automated alerts can be issued. Personal shark deterrent devices, electronic systems that create electromagnetic fields supposedly off-putting to sharks, are marketed to individuals. The goal is reducing risk without killing sharks. Medical care makes an enormous difference. Many shark bite victims now survive due to rapid trauma care. Historically, most shark attack victims died from blood loss before reaching medical care. Today, with improved emergency response, helicopter evacuation, and advanced trauma care, survival rates have increased dramatically. Many victims who would have died decades ago now survive, though often with significant injuries. The improved survival changes the statistics: more attacks but proportionally fewer deaths. As we conclude our journey, we return to creatures small and often overlooked, yet responsible for more deaths than many famous dangerous species combined. The statistics surprise most people. European honeybees cause more deaths than many famous native species. Bees killed more people than sharks, crocodiles, or any venomous snake species individually. 31 deaths from bees versus 27 from sharks, 21 from crocodiles. The tiny, seemingly benign honeybee, an introduced species valued for pollination and honey production, proves statistically more dangerous than the iconic predators that dominate our fears. The mechanism is entirely different from venom. Most bee-related deaths are due to anaphylaxis. For most people, a bee sting is painful but medically trivial. The venom causes local pain, swelling, and redness that resolves within hours or days. But for people with severe allergies, a single sting can trigger a massive immune overreaction. The body's own defense system becomes the danger, releasing histamines and other chemicals that cause blood pressure to plummet, airways to constrict, and systems to fail within minutes. The prevalence of severe allergy determines the scope of the problem. Around 1 to 2% of people may experience severe allergic reactions. In a population of 25 million, that's potentially 250,000 to 500,000 people at risk. Most don't know they're allergic until they're stung. Some develop the allergy later in life after being stung without incident previously. The unpredictability makes bees a hidden danger for a significant minority of people. Geographic ubiquity amplifies the risk. Bee stings are common in both urban and rural Australia. Unlike crocodiles confined to the north or box jellyfish limited to tropical waters, bees are everywhere. Suburban gardens, city parks, farms, bushland, bees are present anywhere flowers bloom. The frequency of exposure, millions of people living and working in bee habitat, inevitably results in regular stings. When combined with the percentage of people with severe allergies, deaths become statistically inevitable. Wasps present similar risks. Wasp stings can also cause anaphylaxis. European wasps, introduced species that have established in southern Australia, are aggressive and can sting repeatedly. Like bees, they cause most problems through allergic reactions rather than venom toxicity. The symptoms are identical: anaphylaxis triggered by immune overreaction to relatively small amounts of venom. The true scope is probably underestimated. Many sting reactions are underreported. Mild allergic reactions, non-fatal but concerning episodes, people who had severe reactions but survived with treatment, these don't always make it into official statistics. The number of serious reactions vastly exceeds the number of deaths. And in remote areas, deaths from anaphylaxis might be attributed to other causes if the sting wasn't witnessed or the connection isn't made. Ticks present another hidden danger. Ticks can cause tick paralysis in pets and occasionally severe reactions in humans. Paralysis ticks inject a neurotoxin that can cause progressive paralysis. In dogs and cats, tick paralysis is a common emergency, often fatal if untreated. In humans, it's rarer but can affect children. Some people also develop severe allergies to tick bites, including mammalian meat allergy triggered by certain tick species. It's a complex array of tick-related health impacts. Even caterpillars and moths demand respect. Certain caterpillars and moths cause painful dermatitis. The white cedar moth and processionary caterpillars have urticating hairs that cause severe skin reactions, eye damage if they contact eyes, and respiratory symptoms if inhaled. People working near infested trees can develop debilitating reactions from repeated exposure. It's not life-threatening in most cases, but it significantly affects quality of life and work capacity. Other arthropods cause localized problems. Some centipedes and scorpions cause intense local pain. Australia's centipedes can grow quite large and deliver painful bites from modified legs that inject venom. The pain can be severe, lasting hours. Scorpions in Australia are generally not as dangerous as species from other continents, but stings are very painful. Neither typically causes death in adults, but both can make a victim wish for death during the hours of intense pain. The overall message of vigilance applies across all species. First aid guidelines emphasize monitoring for allergic reactions after any sting or bite. The critical period is the first hour after a sting or bite. Symptoms of anaphylaxis include difficulty breathing, swelling of the face or throat, dizziness, rapid pulse, or sense of impending doom. These require immediate emergency treatment with epinephrine and rapid transport to hospital. Even people without known allergies should be monitored after stings, as anaphylaxis can develop on first exposure or in people who've been stung safely before. And so our journey through Australia's dangerous animals comes to a close. We've learned that reputation and reality often diverge, that statistics tell stories different from headlines, that medical science has transformed outcomes, that coexistence is possible through awareness and respect. Australia is home to some of Earth's most venomous and dangerous creatures. This is true, undeniable, remarkable. But it's also home to millions of people living ordinary lives, swimming at beaches, hiking in bushland, working in fields, rarely encountering dangerous wildlife and almost never being harmed by it. The danger is real but manageable, present but usually avoidable. As you drift towards sleep, let these thoughts settle gently. 27 deaths from sharks over 16 years, across a continent with 25 million people. 37 deaths from snakes, in a country with more venomous snake species than almost anywhere. No deaths from spiders in over 40 years, though deadly species remain common. The numbers tell a story of caution without terror, of respect without paranoia. The animals themselves are simply being animals. Snakes strike defensively. Spiders bite when threatened. Crocodiles hunt as they've hunted for millions of years. Sharks patrol their territories as apex predators. None harbor malice toward humans. None seek us out. They simply exist, pursuing their ancient survival strategies, occasionally crossing paths with us in ways that end badly. We can coexist. Modern medicine provides the safety net. Education provides the knowledge. Awareness provides the protection. Australians have learned to live alongside their dangerous wildlife, to check boots for spiders, to scan water before entering, to give snakes wide berth, to respect warning signs. It's a relationship built on knowledge rather than fear. And perhaps that's the real lesson. Fear is natural, even appropriate in some measure. But informed respect is better. Understanding is better. knowing when to be cautious, where danger actually lies, how to respond if something goes wrong. This transforms nebulous dread into practical wisdom. Rest now. In this understanding, Australia's dangerous creatures continue their lives, as they have for millions of years. And humans continue theirs, sharing the continent, usually peacefully, occasionally clashing, but mostly coexisting in a complex dance that benefits from knowledge, respect, and modern medical science. The funnel webs are in their burrows. The brown snakes are hunting mice. The box jellyfish are drifting with the tides. The crocodiles are still at the water's edge. And you, far from harm, can rest peacefully, knowing the full story. Sleep well.